Good morning, or it's morning for me anyways. Hope everybody's doing okay today. Going to talk a little bit about linear, quadratic, and exponential functions and how you can tell from looking at the data how to get there. So when you are looking at your information, here you got your x's and your y's in a little table. You want to figure out, well, what do I get when I look at this stuff? Now, I'm going to go ahead and say, I like my pictures, and when you see the pictures, it's like, oh, that makes a line. That must be linear. Oh, that makes a parabola. It must be quadratic. Oh, that's that exponential curve. That must be exponential. So the picture tells a story, but if you aren't really fond of plotting all the points and figuring it out that way, you can look at the table and get the table to tell you. Now, the first thing you've seen this before, when it's linear, I hope you recognize this as being linear. If I look over here, I'm going 2, up 2, up 2, up 2, up 2. So I got a constant on this side. And over on this side, I go, oh, wait a minute. Come on, this way. Oh, when I do go from here to here, it's 4. And when I go from here to here, it's 4. When I go from 7 to 11, that's 4 as well. And 11 to 15, oh, it's 4. I got a constant of 4. As you're going to see in the Khan Academy videos, that I'm being very specific. I'm taking a function and putting the function in the table. But in real life, you don't really have a function that puts into it. It might lend itself toward something. That's why we call it a model. But I'm actually doing the straight out math. We're not doing the modeling. So if you see this and you see it's going up by a constant rate of 4, that's my rise, and my run is 2. So this would have a slope of 2. So hold on. Let's see what else we got over here. I think I can just go like this. Oh, yes. And then, okay, behind the curtain is the graph. And oh, look. Oh, come back. Sorry about that. You look and you go, oh, there's a line. I could take a line right there, and oh, I could connect A to E, and oh, look, they all line up. And what am I doing? I'm going, how much am I going? I'm going from -1 up to 3, that's 4, and a run of 2, oh, 4, 2, oh, the slope of 2, it's got a slope of 2, and a y-intercept of -1. So the equation for this line would be y equals 2x, remember y equals mx plus b, y equals 2x minus 1. That's the equation for the line, but that's not what we're looking for. We're just seeing, what is it? Is it linear? Yeah, that's linear, it makes a line. Okay, next slide. Okay, what about this one? All right, now we look again over on the x side. We go from 0 to 2, that's up by 2. 2 to 4, that's up by 2. 4 to 6, that's up by 2. All right, so we see the constant. We got a constant run. We have our x's are increasing at a constant rate. Delta x, as we go further down the math path, you will learn that as delta x. Delta x is a constant in this example. But now when I look at the y's, when I go from 2 to 1, I went down 1. So -1. There's my -1. And then I'm going from 1 to 4. Oh, that's up 3. And then when I'm going from 4 to 11, I went up 7. I went from 11 to 22. I went up 11. And that is definitely not constant. Those aren't the same number. But I feel like I've seen those numbers before. 1, 3, 7, 11. Oh, wait a minute. So wait a minute. When I do it a second time, if I now look at the difference between the -1 and the 3, what is that? That goes up 4. And 3 to 7, oh, that goes up 4. And 7 to 11, that goes up 4. So I have a constant. It didn't happen the first difference. It happened on the second difference. And so when we have it on the first difference, it's a first-degree polynomial. And when you have a constant in the second, when you do it a second time, oh, that means it's a second-degree polynomial. That means that this thing is a quadratic. If I go over here and plot the points, all right, once again, I should go like this, and there's nothing there. I'm going to move my little screen. If I plot these points, I'm going to see a parabola. I know it because I got a constant in the second thing. If it's right here, if you have a constant going down the first time you do it, it's linear. And if it's a constant on the second difference, it's a quadratic. And I'll go ahead and tell you if it's a constant, if these were all different, but I had a constant in the third one, it would be a cubic function. And look, you can see your parabola. It's going down, 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 and over here, somewhere in here, it hits the bottom, the vertex. I'm going to tell you it's at 1/2, 1.5, 3/2, and then it keeps on going up. When we get to algebra 2, we're going to figure out how do we figure out what that parabola is. But right now, just recognize the fact it's a parabola. It makes a parabola. It's not exponential because you see you got this little down part over here. It goes down and then back up. That's the parabola. Exponential, it would just go up, 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 up. All right, so that's a quadratic. And then finally, okay, now over here, what's going on? We're going, again, the x's are the same. We got delta x is the same on this one. 0 to 2, 2 to 4, 4 to 6, 6 to 8. Yeah. And now, but what happens when I look at 2 to 4? That goes up by 2. And 4 to 8 goes up by 4. And 8 to 16, that goes up by 8. And 16 to 32, that goes up by 16. Huh. I feel like I've seen those numbers somewhere before. Wait a minute. 2, 2, 4, 4, 8, 8, 16, 16. Oh, something strange going on here. Okay, I don't have a constant. And then if I did it again, I look at the difference. Oh, it's going to be 2 and 4 and 8. I feel like I'm seeing these numbers over and over again. So instead of getting added, we add the same number each time. We're multiplying. Oh, look, it's a doubling factor. From 0 to 2, I go from 2 to 4. It doubled. And when I will go from 2 to 4, it goes from 4 to 8. It doubled. And when it goes from 4 to 6, it goes from 8 to 16. It doubled. So this is a doubling factor. So it has to do with multiplying a bunch of times. And multiplying a bunch of times is that exponential stuff. So when I come over here, and I'm a big fan of the graph. When you graph it, you see, once again, you could think maybe this is a problem. Maybe it goes up over here. But from the data that we have, it looks exponential. And we can get further, as we get further down that math path, we can figure out ways to determine that. But that would be an exponential function. So being able to look at the data and decide whether it's linear, quadratic, or exponential is what we're looking for this week. Okay, hopefully that will help. Good to be back. Hope that helped.